Hello and welcome to today's video. Today we're talking about paradoxes of scale. So, Hilbert's infinite hotel. Hilbert's infinite hotel is an analogy used to help people understand or used to analyze the properties of transfinite numbers such as Aleph and Null. So imagine a hotel with Aleph Null rooms. Every single room is full, and in a normal hotel, you just be turned away. But in this hotel, they can accommodate for another guest. Let's look at how this is possible. So, case one: a new person goes to the check-in desk and they're like, "I want a hotel. I want a room at this hotel," and they're like, "We're full, but we can arrange something for you." So, to fit in the extra guest, the manager asks everyone to move one room down. Guest one moves to guest two's room, and guest two moves to guest three room, and so on. And room one is empty, and this means that the person can check into the hotel. Let's look at the next scenario. So imagine we had an infinite bus. So, there's a bus with Aleph seats completely full, and Aleph people on the bus, and they are all looking for a room at this hotel, Hilbert's Grand Hotel. And so, how exactly would we go about how exactly would we go about creating space for these people? Because obviously, there's only Aleph rooms in the hotel itself, and this is completely full already. Well, if you watched my previous video, you would know that the amount of even numbers is the same as all of the numbers, the natural numbers. So if you were to if you were to times every room by 2, so let's say the person in room 1 moves to room 2, the person in room 2 moves to room 4, the person in room 4 moves to room 8, the person in room 3 moves to room 6. So all of the odd number rooms would be empty, and each person on the bus on the full of Aleph Null people would move to an odd number room, and thus, even though the hotel is full, it will still be able to accommodate another Aleph Null people. So what does that actually mean? It means that if you were to add Aleph Null to itself, it would still be Aleph Null. And so it's important to remember that transfinite numbers, they follow the rules of transfinite arithmetic. So they don't follow the usual rules of 1 plus 1 equals 2. They have their own sort of laws. And it does also make sense because if you have something that's infinite and you add it to itself, it's still infinite. It can be confusing to think about, but I think the hotel really helps. So, is all infinity the same? We've already talked about how if you were to add to itself, Aleph Null to itself, it would be still Aleph Null, but are there any larger infinities, or is it just Aleph Null itself? As you can see, there's a little hint there, there's sort of a staircase, sort of a hint to where we're going in the next video. But briefly, I wanted to talk about if you wanted to do Aleph Null minus itself. This is a question I had doing my own research on this topic. If you were to subtract Aleph Null from itself, it's sort of undefined because, as you know, infinity is infinite. So technically, if you were to take infinity away from itself, it could be 0, but it could also still be infinity. Because if you add infinity to itself, you get infinity. So if you were to take infinity away from itself, so just imagine an equation where you had infinity plus infinity equals infinity. So if you were to take infinity away from both sides, you'd still have infinity minus infinity equals infinity. This way of thinking about it. And if you were to do, going back to this example, if you were to do an aleph null number of these buses, then it wouldn't work. If you were to times infinity by itself, then we end up getting into something I'll get into in the next video. So stay tuned for the next video. And it's been a pleasure talking to you guys about this. I'm really passionate about this topic. So if you wouldn't mind sharing it if you found it interesting, liking and subscribing. And yeah, I'll see you in the next video, which is going to be on diagonalization.